In this video, we are going to go over the task of segmenting a structure using ITK-snap segmentation tool and converting the result into DICOM representation using dcmqi converters. In preparation to this video recording, I saved the DICOM dataset into a temporary directory and installed ITK-snap on my computer. I'm going to launch ITK-snap and load the image data, which is a DICOM series. And you will find a link to the DICOM series that I use here in the supporting materials for this video. So, as you can see, it's an MRI series of the brain. And for this simple example, I'm going to segment ventricles, just to make it quick for the demonstration purposes. I'm not going to describe you how segmentation is done using ITK-snap in detail, but you can check out ITK-snap homepage for the very excellent tutorials that they provide that should be able to help you with the segmentation itself. Our tutorial is focusing on the conversion task, and I'm going to just go over these steps to create the final result. So I created the speed image. I'm going to create this label, which I will call ventricles. Note the color of this label. Next, once my speed image is ready, I'm going to create initialization for the segmentation process. I'm going to place some bubbles, and I'm going to launch the segmentation. As you see, the segmentation contour is evolving, and very quickly it covers the space inside the ventricles. Looks good to me, so I'm going to stop. You can see the result is overlay here and as a three-dimensional structure here. So that's the data set that I want to export into DICOM. And in ITK-snap, I will use the segmentation export into NRRD image format. It's a very popular format in the image processing field in clinical image analysis. And I'm going to save this result as NRRD file into my temporary directory side by side with my DICOM data. In our directory, we have the folder with the source DICOM data, and we have the ventricles segmentation result saved as a NERD file. What we have to do next is to create the metadata saved in Json to facilitate the task of conversion. To help with this task, we created a web application that allows you to populate in a visually convenient manner different attributes that are required by the converter. So, for the content creator name, I'm going to put my name. For the series description, which is a free text field, segmentation of ventricles. For the body part examined, it's a brain. Here I'm going to choose the list that defines the terminology to be used. And I will need to populate this form for each of the segments. In our instance, we have only one segment. I will put again description of this segment. It's ventricles, segment algorithm name ITK-snap. For the segmented category, the choice here is anatomical structure. And now I can start typing, and I see that brain ventricle is a good match. I will initialize the color to be the same color that we used in ITK-snap. That also can be communicated in the metadata file. And now one very important attribute here is this label ID. Label ID is the number that links the section of the JSON file describing the segment with the label saved in the NERD file. So if I go back to ITK-snap, I can see that the label that was assigned in the output segmentation image is 5. This means I need to specify 5 in my metadata. Now I am ready. I generated this JSON content. I will download and save it into the same directory where my segmentation and source DICOM data is located. So now we should be all set to do the conversion. I pre-populated this command line, but let's take a moment to look what is here. The important argument to the run command is this -v flag that essentially provides access to the converter to the content of the directory with the data. So that directory, where I have all my data, will be mapped to TMP dcmqi directory. Now I need to use the command line arguments to specify the input DICOM directory. That's where the source DICOM files are located. The path to the input metadata in JSON format, input image list, which is short, just one file with the ventricles segmentation, and the file name to store the result of conversion in DICOM. I run the converter and it's completed successfully, and now I can see the result of conversion DICOM file saved in the same directory.